Hello, Vikas.
Yes, sir.
Good morning, sir. Good morning. Sir, I have class from 10 to 12, sir. Sir, good morning, sir. Hello. I have class from 10 to 12, sir. So you could manage, na, sir. So this 2 hour, this first session. Okay, sir. Okay, sure, sir. Okay, sir. Hello, Vikas.
Yes, sir.
So I made you as a co-host. Okay. Okay.
Okay, sir.
We just manage the recording as well as the streaming everything.
Okay, sir. Sure, sir.
So I have class from 10 to 12. So today morning both sessions are the from Vinayak sir only.
Yes, sir. Yes, sir. I saw the video.
Okay then.
Okay, sir. Waiting for Vinayak, sir, to join.
Hello.
Hello.
Good morning, sir.
Yeah, good morning,
Actually,
Dinesh. Sir will
the
going to join shortly.
got it point. सर द मंडे को जो सर ने एक्सेल शीट शेयर किया तो वो हमें हमें अभी तक मिला नहीं सर. आप आज कर
मैंने
सकते हैं?
शेयर किया ना मंडे वाला yesterday.
Uh,
I have shared in the group actually. Check it.
1 minute. हाँ. Yes, sir. Yes, yes. Sorry, sir. Got it.
Good morning, sir.
Good morning, sir. Sir, are
Sorry,
you
sir.
mute?
You're muted, sir. You're in mute.
Hi, good morning, everyone. Good morning. How are you all?
Fine, sir.
Good, sir.
Yes.
How
Uh,
about you?
should we wait or should we start?
Just 2 minutes, sir. I'm dropping a message in the group so that
Okay,
everyone can join.
sure thing.
We can start the session, I guess, sir.
Hello, everyone. Can you see me? Yeah, can you hear me?
Yes, sir. We are able to hear you.
Okay, perfect. So one of the things I had promised yesterday was we'll I'll go through the nested logic. So I had to run some estimates separately. So I'll go through that for the first 5-10 minutes, and then we'll spend some time on the transport economics piece again. Like go back and do some additional concepts around economic assessment. All right, and this time from a logistics perspective. So let me start. All right. So let me see if I can share my screen. You should be able to. All right. So if you remember from yesterday's discussion, just drop. I shared the entire data, right? Like this was the data which we had discussed and I shared with you yesterday. It had all this information about the households and the individuals who are making choice on the left side, and then more mode specific information on the right? And we did an MNL and we got results. When I'm talking about MNL, it is multinomial logic model. Correct. So one of the fundamental assumptions about multinomial logic model is that that each of the um, each of the factors are independent and identically distributed. But one of the things which we do know when we did the red bus blue bus problem was that it matters if they have if two modes are highly correlated and can be seen together as one option, then you need to be able to appropriately correlate them into something called a nested logic model. So one of the things we identified yesterday was that walking and bike would be active transport, bus and train is public transport, ride hail and car, right? Car has a ASC of 0, the attribute specific constant as 0, was coming out to be car. So basically you're going to have three options, basically three nests, and within each nest there are options. So how does a nested logic model work, right? So we did a little bit of the framework, but I wanted to go through a little bit of the uh, the maths behind it. So let's go back to, where was that? Yeah. I didn't do nested here, not included nested in this part. One second, just give me a moment. It's not in a lot of slides. Trying to look at not this one. I think, yeah, this one. So when we did the sorry, please 1 second. Just getting, just give me 1 second. Sorry, it's an urgent call. Sincere apologies. It was just an emergency that had happened, so, or taken care of. So I'll just go back to my slides here. So when we were doing this, if you remember, the way we had set this up was that you have a first choice between a passenger car and transit, and then within a passenger car you have a utility of driving alone or a shared, right? So the probability of taking driving alone is the probability of choosing a passenger car multiplied by the probability of choosing driving alone given it's a passenger car. So it's basically a Bayesian probability, right? So how do we represent this in a mathematical nested logic perspective? So the way it is, this thing is the lower level. You remember the lower level, which is basically each of the modes, is a given A. So given that there's we are taking a car, so which is mode M. So let's say given we are taking transit, what is the probability of taking a bus? So that is within the transit, what are the different options? So this will be exponent of the utility of the transit plus the bus plus the train, and you'd get this. Now within that nested probability, which is on the top level, the probability of taking that mode is what the way you do that is by adding this log likelihood. So you take the sum of the exponents and put that on top. And you have these parameters which are called lambdas, right? Lambdas, it is telling you how much is people are preferring each of the different type of, so in some sense, it's an attribute specific preference, the lambda and lambda k. Am I making sense so far, or it is actually a 3-hour lecture on just on nested logit models, but I'm just giving you a sense of the key concepts. The key concept is you have a nested logit model, which is this part, this lower nest driving alone. And when you come up, when you look at UPC is nothing but exponent of lambda times sum of this, log of sum of this, right? So that's what you're trying to do. I'll just go back here. Log of sum of this. So these are also called the log likelihoods. So when we estimate this, we get this result. All right. So what you will notice is that I have an attribute specific constant for ride hail and for bus, but I don't have it for others. All right. And the other thing to remember, because you've got the lambdas playing out now. If I look at IVTT, the coefficient of the in-vehicle travel time, and that's minus 1.42398. What did we get here? Minus 0.0361. So your coefficients actually change. And if I look at this, the cost is minus 0.1735, and this is minus 1.3007. So the value of time now here is IVTT by cost. So if I do 1.3 divided by 1.4, it is close to 1, as opposed to here, which was more like 0.17 divided by 0.03, it was close to 4. So if you don't do a nested logit model appropriately, you might get very different values of time. So you were getting $4 a minute, while here you're getting $1 a minute. And these lambdas are what we talked about, right? Like the lambdas associated to so these are the lambdas. So for car, for transit, for a car, it's 1. For active transport, it is 0.44. Are you getting a little bit of a sense? It's actually a 3-hour lecture, but I just wanted to show you that when you run the model using maximum like MNL, you end up with different results.
Okay.
Any questions so far? Lots of questions, I would imagine, but the main thing which I want to try to give you here is the intuition that when you're developing your model around mode choice, try to make sure that if it is nested, try to ensure that it is appropriately captured in your modeling assumption. Okay. Any other questions? All right. So if there are no questions, then I will move to the next part of this this thing, where I'm going to talk more in depth about the transport planning process, the economic models, as well as the different types of models as well. If you remember, I said that we will discuss a little bit about different types of modeling approaches. So we'll go through that. And I'm going to take an example here in Sydney about how to go about it. All right. So this is this thing. So why transport planning matters, and we have discussed this at length, is we have a lot of avoidable congestion, and the expenditures by governments are in billions, and particularly in India at a national level, it is in hundreds of billions of dollars. So how do we actually end up efficiently dispersing it? That is always the question. How do we efficiently disperse this money? So this is just some of the examples. Like the thing about the transport is, it will always be there will be always stories in the news. There'll be always stories on Twitter and always stories on LinkedIn about how bad the congestion is and how people think that they could be spending the money better, right? So that is what this whole process is about. Any questions? So the transport development process. So generally you have 3 stages. The first stage is the planning, then the detailed design, and then the construction. Where most of our work and our discussions are sitting today is in the planning process. All right. In the planning process, first of all, we need to identify the problem. So for instance, for a city, the problem might be mobility of people. All right. So every city ends up developing a comprehensive mobility plan every 5 years at least. In that, it identifies that where are the main choke points, what are the main issues for public transport, etc. Right. So that is the first piece, which is the problem identification. Then you come up with design options, which is basically also the same as scenarios. So the different scenarios. So for any problem, like for a bottleneck, you could end up developing solutions all the way from increasing the number of lanes to having flyovers to actually shutting down that road and making it pedestrian or all pedestrian. These are all valid and viable design options. But the question is, which one makes sense and which one would actually provide you the most benefit? So that's where the appraisal comes in. All right. So you're able to go through different scenarios, compare them, and say that this is the best. Any questions so far on this? So that is fundamentally what happens at a transport development perspective. And in all of this, you have transport planners, engineers, and economists. And I would always argue that the best transport professionals whom I've seen are able to span across these three. When I say span, they're able to understand the problems, what a planner has. That means get involved in the problem identification while developing engineering solutions and thinking about the economic implications of it. Because otherwise, what generally ends up happening is a planner would come up with really, really novel, innovative ideas and options, but it might not be economically feasible. So that is where a lot of the value would sit, and hopefully that's what this course is trying to address. It's trying to create, like a lot of you are already planners or engineers, but this course is trying to get you a sense of how an economist works. How do you do appraisal? And at the end of the day, what you'll find is I think one of you had actually mentioned in the very first lecture, performance indicators. It all goes down to setting your performance indicators and being comfortable that these performance indicators are going to be changed on you. So you will come up with a certain this thing, and then the government will say, all right, but have you considered this? Have you considered that? So you have to be comfortable in incorporating that. So the transport planning problems can be considered across three areas. One is a policy level, which is looking at fares, congestion pricing, ramp metering, registration costs. We talked also about fuel excise, etc. Network level, which is more corridor and precinct planning, which is essentially associated to the comprehensive mobility plan. And local level, which is more a traffic engineer's job around intersection upgrades and road widening. Now, one thing I forgot to mention here. When we talked about a lot of these problem identifications, design options, and appraisals, we only talked about mobility of people. So if you look at a comprehensive mobility plan, almost 95% of the whole discussion of the comprehensive mobility plan is around the travel time of the commuters and the bottlenecks experienced by people traveling. Freight is usually missing in it. So a lot of cities are now coming up with a comprehensive logistics plan. Where should you put your warehouses? What time of the day you should be traveling? How can you actually improve the logistics and goods movement in a city? Right? Any questions? Any questions so far?
No, sir.
Okay. As well. So in transport modeling, and we discussed this in the first lecture as well, the whole purpose of all of these models is to evaluate a performance indicators. So the point is you have to go with the humility that all models are wrong, right? And some are useful. So the main premise around this statement, and this was made by George Box, and George Box is the one who you must have seen in statistics, you have these box plots, right? So these box plots are basically were proposed by George Box, and he's also got a lot of statistical tests between looking at the different distributions. But the fact that all models are wrong but some are useful, it brings the humility that every model has assumptions, and what we are trying to do is trying to find a model that people are agreeable to, which can then inform the decision process, right? So that is fundamentally what we are looking at. And in transport, we generally look at the 4-step model, and I think all of you have talked about it. We have a trip generation, distribution, mode split, and then assignment. We have gone through demand models as well. So in the demand models, we did not focus so much on generation distribution, because generation is generally empirically determined. So let's say there is there's an office space, then you have a trip generation of a trip attraction of certain multiplier. If you have a trip attraction, if you have a certain residential area, you have trip production. There is not, I would say, not much science, or like when I say science, it's all based on empirical information. So we didn't spend too much time on that. You can get a lot of these through IRC or other documents, ITE in the US, etc. Trip distribution is, given an attraction and production, how do you actually get people to move? And that's where there was a discussion yesterday around looking at gravity-based models. There are other models now which we have moved away from gravity. You can actually look at AI-based models which you calibrate on and then implement it in a new region. What we basically spent a lot of time on was mode splits. And in the network modeling, and we have not spent time on network modeling, we'll probably do that tomorrow. We will be spending time on it tomorrow, is essentially looking at macro, meso, and micro. And we discussed that as well in the first class. The macro is a static model where the travel times on each link are independent. Mesoscopic is you have queue spillback, and it is dynamic. But what you're doing is you're looking at it as a flow of a vehicle. So you're not looking at acceleration, deceleration patterns for every vehicle. And then the final one is micro simulation, which you're looking at for every individual vehicle. Any questions on this so far?
No, sir, it is clear.
Yeah. All right. So generally, when you're doing, so this is the first piece, when you're trying to develop, do an economic assessment or any kind of appraisal, you have to write a report, and generally you structure the report in three sections, three main sections. First is the background section, where you're actually providing the existing conditions, information about the existing conditions. Sorry, just give me 1 second. So the first part would be actually providing the base conditions, which is the existing scenario of what the problems are. So it's essentially doing a problem identification and diagnostics. The second part is basically your proposals, which is essentially your different scenarios which you're providing, and the analysis associated with that. And the final thing is the recommendation. And we will try to go through that approach in the example we're going to go through. So this is a Windsor bridge replacement. So Windsor is a part of New South Wales, which is up in the northwest of Sydney. And it's a major, so this Hawkesbury River is a major river across New South Wales, and there was a heritage road here. Now, the problem is that the structure has deteriorated and there is regular floods. So one of the things which you want to think about when you're doing a lot of these bridges in your cost benefit analysis is, one is, what if the bridge is not there? But the second is also, how many times will the bridge be flooded? So if the bridges are too low, they get flooded. So if they are flooded even 5 times a year, it's a problem. So what you want to be doing is also incorporating the resiliency and vulnerability aspects into your assessment, right? So that would then determine what is the appropriate height you want to put the bridge at. Any questions?
No, sir.
So this is the current scenario. So so this is the Windsor Road, and you have this bridge which goes through here, and we have come up with like 1, 2, 3, 4, 5, 6, 7. You can come up with, we've got 7 different types of scenarios for this region, and we'll talk through this. We'll talk through each of them and how we can evaluate, etc. All right. So there is an existing option where in the morning peak, your total travel time is 508 vehicle hours. So that is the total number of vehicles multiplied by the travel time, right? So 508 vehicle hours. So if it was 30 minutes, the travel time was 30 minutes, then you would have 1,116 vehicles. Then your average speed is 40.5. In the afternoon peak, your total travel time in vehicle hours is 649 with an average speed of 38.5. So there are all these assessments that have been performed. Now, what is the cost associated to it? So there is there's a cost, and the left one is talking about the benefit. So if you have an existing, this is 508, 40.5. Option 1, which was, if we go back, this is option 1. Option 2. So what you'll notice is each of them has different vehicle time. Now, like for instance, let's look at option 4. The total travel time. So the speeds, the average speeds remain the same, right? So what is option 4? Option 4 is going through here and coming down here. So basically your travel times are remaining pretty much similar to that what it was. The speeds are similar, etc. So what is the cost for each of these? So the cost of just closing the bridge, that's a capital cost of 540,000, and you then do a present value of that from our RTA estimate, and a net present value, the present value of the increased travel costs as well. So you can do an assessment based on the cost, and you can look at the benefit to cost ratio for each of these, right? So we did that assessment, and based on this, what you'll see is option 1 and option 2 are the best. Option 4 is the second best, even though the total vehicle travel time has increased 513. Still, option 4 seems to provide the second best thing, or third best. So this is pretty much how we do this assessment, right? We've gone through that, and eventually what was built was 1 and 2, option 1 and option 2. So which was basically you had a shared pedestrian pathway that was built around that, and there was an expansion in the road as well, right?
Yes, sir.
Now, the transport appraisal. So how do we choose which option or projects to implement and in what order? So appraisal assigns a value of impact, that is cost benefit, and cost benefit analysis, cost effectiveness analysis, multi-criteria analysis is all part of that appraisal. And there are three types of assessment. One is the strategic merit test, which is a strategic business case which you put forth, that we want to reduce the travel times or reduce the travel times by 5%, or we want to have a 30-minute city, right? These are all strategic merit tests. The next one is a rapid appraisal. A rapid appraisal is doing an initial test of whether it actually makes sense or not, right? Just doing a desktop analysis of whether we should be actually looking at improving the road or putting in a public transport, just an initial assessment before you even do a detailed appraisal, because modeling is not a cheap exercise, right? People end up spending millions of dollars on doing developing a model and then doing an assessment. So there's an aspect of actually doing a rapid appraisal and culling the options which you might not want to do. Any questions so far? Let me just. Again, we've gone through what a cost-benefit analysis looks like and doing a risk and sensitivity. So one of the things about this, we've also done the concept of discounting. We've spent time on that, but also doing sensitivity analysis. We discussed that in passing, but because we are making a lot of assumptions when we do our developing a model, it is important to do sensitivity associated with those assumptions, right? Those assumptions could be based on the forecast of the traffic volumes. It could be based on based on the value of time. So what you do is you change it by plus minus 5% and see whether the results, the ranking are still very stable. All right. Again, we spent a lot of time on this, so I'll skip this as well. So when we were doing our benefits, we talked about travel time savings, we talked about cost savings, we talked about accident reduction, and I want to spend some time talking through how we should be looking at. So we didn't have much. When we looked at the demand, we did some aspect of elasticity, right? Remember the airline problem, where when we reduced the price, we actually ended up increasing our revenue, right? In yesterday's class itself, if you remember in the first class, we actually did that, so when we are looking at user benefits, the total user benefits, we need to be able to capture the impact it would have on the whole demand. So this is basically telling you that the train trip from A to B is on average, is $15, which is the generalized cost. So $5 plus 30 minutes multiplied by $20 an hour. That's $20 an hour is the value of time. So if this is my generalized cost, what it is telling you is that if I reduce my generalized cost from 15 by $1, 14, it will increase the number of trips. And as we keep reducing it, right? Sorry, so this is $30. If I keep reducing it, the amount of demand will increase. The number of trips will increase. So currently for $15, we have Q1 trips, let's assume. Now we reduce our fare, reduce the travel time to 15 minutes. So the moment we reduce our travel time to 15 minutes, the generalized cost becomes $10. And the number of people coming in has increased to Q2. Right? So my total benefit, which I would have realized, is this shaded dark green, right? Dark green piece, which is on average $5 for the people who are already there, plus the extra people who have joined will have an average of 2.5 because it's a triangle, right? So this is 5 and this is Q2 minus Q1. 5 divided by 2 multiplied by Q2 minus Q1 divided by Q2 minus Q1 is half, 2.5. So these people would have experienced on average a $5 improvement. These people would have an average improvement, a reduction in generalized costs of 2.5. Any questions?
No, sir.
Am I making sense? I'm not having very many questions. I'm just wondering if you all have, if it's making sense or not.
Yes, sir.
Or am I going too quick?
No, sir. No, sir.
So this is going to, I'm going to go through an example again of 4 options to add ramp meters to M4. There are 5 scenarios, which is the current scenario, which is the base. Then 4 additional options, 1 to 4. And the benefits we are going to be experiencing are either travel time savings and vehicle operating cost savings. Okay. So this is our example. So the total travel time in hours. So that's the number of vehicles multiplied by their travel time is 250. Right? So the average travel time is 250 divided by 1000, which is 0.25, which is basically 15 minutes. Okay. So there is no, this is the current situation. So there's nothing, we can't, the concept of travel time savings, vehicle value of time, none of this makes sense right now. Then option 1, let's say we are putting a variable speed limit, or let's say we have put in a ramp meter, all right, the ramp meter. So the total travel time has become 275. That is because you have 150 vehicles more as well, right? So 1150 divided by 275 is roughly 0.24. So the travel time savings is 0.01, which is it's 0.01 multiplied by 60 is roughly 0.6 minutes, right? Is it? Yeah, 0.6 minutes. So that's basically 0.6 minutes is roughly 36 seconds. So on average, we are saving 36 seconds here. The value of time is $15 per occupant hour, right? And the occupancy is 1.4. So the total hourly benefit is value of time multiplied by the occupancy multiplied by the total vehicles before 1000 multiplied by 0.01, because that's what we'd be saving on, which is equal to 210. So you can actually identify that through each of these. So this one has 630. Here we don't have any benefits because the the travel times are increasing by 36 seconds for these ones. So you end up having minus 210, minus 210. Here the travel time starts reducing by 0.03. So you end up having almost 3 times that benefit. So that's become 630. Any questions so far?
So in this option, sir, we have considered only a base year or any tentative year we also considering. And for example, for this travel time saving, we are considering in year 2020-25. So we have considered in means 2030, 35, 40 in manner or only consider only 2020-25.
When we are doing base scenario,
Hmm.
we are looking at the base scenario in 2025. Oh, no, 2030. Not today.
Okay. Okay. मतलब five after in base year we are considering the construction time also.
Yeah. So the first thing is when we are looking at benefits, right?
Hmm.
10 years from now,
Hmm.
the base case is basically a do nothing scenario. If you did nothing 10 years from now, what would be the number of vehicles? What would be the total travel time?
Okay.
Is how you would compare option 1, option 2, option 3, option 4 for 2030.
Oh. With the
Does
reference
that
of
make sense?
base.
So you would not be
Yes.
comparing
Mhm.
option 1 of 2030 to the base scenario of today, of
Okay.
2025.
Mhm.
You want to be comparing them for the same year.
Okay. Got it.
This one basically talks about how you identify vehicle operating costs. Now, vehicle operating costs are generally empirically determined. They're empirically determined for each type of vehicle. Okay, so now you'll have a different formula like this for based on the speeds, journey speeds, for a car, for a truck, for a utility vehicle. You'll have different C0, C1, C2, and also you'll have a different formula for a freeway, which is basically a national highway or a highway, and a urban road, because the wear and tear on urban roads is very different, right? So that is one point. So assuming that we have these coefficients, we can also do an analysis based on vehicle operating costs as well. So very similar. Option 1 actually reduces the total distance traveled. These two increases. This one keeps the distance traveled the same. This one increases the distance traveled, and this one reduces it as well. So based on these equations, you end up with different VOCs. So this is 28.75, 28. So literally, you put in the average speed into these, and you get that. You also have the number of vehicles which you had from the previous as well, and you end up getting the hourly benefits, comparing the hourly benefits. So again, what you find is the option 4 is the best. So one point here, which I'm just kind of reminding myself, is we are normalizing the total travel distance with respect to the base year. All right. So what that means is the normalized travel distance for the base year is 1,000. So that's 1,000 kilometers, right? So what we're going to be doing is the total travel distance is TTD1 right? So that is 950 multiplied by 1000 divided by 950. Not 950, by 1100. You'll get 864. So you're basically normalizing based on the distance and the number of vehicles using it. Yeah.
We also know, sir, which type of mode they are used.
What?
Which type of modes they are using? You have said means number of people are using this.
Oh yeah. So here we have assumed that it's only one type of vehicle. So this is just an assumption. So, but
Okay.
if you have you want to be splitting it up. So this is just giving you an example of how to do it if you have one type of vehicle. If you have 12 different vehicle classes, you will do this 12 times.
For example, we are doing for the public transport that case.
Then you would have a different VOC, cents per kilometer.
Okay. For
And
individual vehicle.
yeah.
Okay. Got it.
And you'll be using different vehicles also. So so the number of buses you'll be taking, right? So that will be another thing.
But the procedure will be same.
Yes.
Okay. Got it.
I'm trying to say, yeah. So yeah. So one of the questions which we have always we are asked is, what is the wider economic benefits, right? What are the wider economic impacts of our projects? So what does a wider economic benefits mean? So if we look at what we have done so far, we have only looked at it from a vehicle perspective or an individual perspective. And the only thing that shows up in our economic assessment is travel time or the vehicle operating cost, right? So it's either travel time savings or vehicle operating cost. But when we put in a road, there are other implications. The other implications as it creates jobs. Because the travel times have reduced, people are starting to live farther away. Accessibility. It also reduces logistics costs. So you have a reduction in what I would call you have reduction in prices of different commodities, because a big portion, almost 30% of the cost of any product is associated to the logistics costs. So if you are able to reduce the cost of logistics, you can potentially reduce the cost of that goods by 30%. The moment you reduce that by 30%, the demand increases. So there are wider economic implications as well. So how do we account for that? That is the question. That is what we keep getting asked. So those wider economic benefits are experienced by people, but also by industries, right? By the land market, the labor market, and all of that. So let's go back to the example of this generalized cost. So we had $15 and $10. So this area gives you the total economic benefits, but it is only associated to travel time, right? But what really happens is that the demand curve also shifts. So originally, if the demand curve was here, because of the reduction, the reduction in prices, the demand will also increase. So the demand is increasing. Sorry, the demand is increasing, but the demand curve itself will increase. So you'll end up having more benefits here. And this is what a wider economic benefit means, is that the entire demand curve shifts. So how do we accommodate for that? How do we accommodate and how do we model that the entire demand curve is shifting? Any questions? Any questions?
Sir, are you mentioning that we are increasing the travel demand timing, so our economy is also the increases?
Correct.
Okay.
So the moment, so that's what the demand curve, so the shift in demand curve is basically saying that because I put a new service in, the entire economy has increased. Because the entire economy has increased, the demand is going to increase.
But
So it's not
yes,
it's
sir.
not only associated to price elasticity, but it's associated to the entire economy actually improving.
Yes, got your point, sir. But it is on the base year, right? After further, the congestion will be increases. As you already said that.
Correct.
Yeah. As you already mentioned that if you propose any flyover, the tentatively 5 to 6 year will be proper traffic will be flow. But after 5 to 6 year, there will be huge congestion in start. So the
So
increasing delay in travel time. So is also
so
affected
we
in.
generally, so when we are doing that, right, like when we do
Hmm.
the congestion coming in, we
Hmm.
actually we model for the 6th to 7th year. So when I'm saying 15 minutes, it is
Hmm.
not that it is in free flow conditions. It's actually 15 minutes after congestion has shown up.
Okay.
But so that's what I'm trying to say is that it will still remain 15 minutes, right? The 15 minutes. But
Hmm.
what is really happening is that the entire economy is improving.
Okay.
Now, because the entire economy is improving, now has increased, the demand has increased. So think about it as induced demand. You put in a new road, there's induced demand.
Hmm.
That means your economy has grown. Now, because of that economic growth, it might not remain as 15 minutes, it might become 20 minutes, but you need to model that. And that's where we are going to talk about CGE models and all of that on how to model it. But that is what we are trying to, and I'm identifying a particular issue which we need to consider.
Sorry, sir. In this modeling, we are which type of software generally use means uh, Visum or Visim? Visum, I
So,
think so.
so two things, right?
Yeah.
In Visum,
Hmm.
do you have the whole demand curve shifting? No.
Okay.
You generally have an OD,
Hmm.
you change the roads, and there is shift in traffic. But it's
Hmm.
not like your entire demand is changing.
Okay.
And the prices are changing and where people are living is going to change. So one of the things you might have also observed is the moment you put in a new road,
Hmm.
like here, like I was trying to, the moment if there was no road, right, that people are living in these high density areas, right? But the moment you put in a road, there might people will move here, people will move closer to the roads. So and then there will be new industry sections which that will also get created. So your demand curve is going to move up. That is something which is not accounted for Visum. In Visum, endogenously, you can. So what you do is you do an analysis before and you say that because you have put in this road, we are expecting a growth in economy by 5%. So based on that, I forecast that the ODs here will
Hmm.
change.
Okay.
Right? So but then you implement those ODs and then evaluate what the benefits are. But in transport economics, we have something called a CGE model where it tells you what the ODs will come up. The ODs will come up on its own. The new ODs.
Okay, sir. Got it.
So in wider economic impacts, there are a lot of aspects which we want to be considering. One is looking at the market imperfections such as taxes and monopolistic firms, and externalities, of course. Like one of the externalities you have is accidents, pollution, etc. And but market imperfections around taxes and monopolies are a big one, which are sometimes really hard to pick up on. Now, the common wider economic impacts are because of agglomeration of externalities, labor market taxes, and market with imperfect competition. There is significant, so in fact, the way to evaluate wider economic impacts change from study to study. In fact, some of them use input output, and we'll talk about that. Some of them use um, uh, something called multipliers. What they'll say is that if you have done a $1 billion investment, then there's a multiplier of for every $1 million, there's going to be 3 jobs that are going to be created in the economy. So there are different ways of actually recognizing and measuring the wider economic impacts. Any questions?
Sir, I have one question.
Yes.
When we decide that this is the 2-lane road or 4-lane or two-side carriageway, so how does it impact the economy and as well as the travel time prediction, or what are the economies we are studying?
Can you
So
ask
does
that?
it relate directly or in the indirect way? Because while doing a life cycle assessment and life cycle cost analysis, we do consider the this part.
So when you're doing the life cycle assessment, it's basically the cost, right? So essentially you're
Yes, sir.
evaluating the cost. But to do the benefits, how are you looking at the benefits? The benefits might show up as vehicle operating costs, the reduction in vehicle operating costs. Because if there's already a 2-lane road, can you tell me a little bit more about the particular scenario you're talking about?
So now, for example, I'm planning a road for state highway. Let us consider a state highway, and now I'm doing the life cycle cost analysis. So
Correct.
for that, if I want to consider a traffic system, so I'm not much considering traffic system, but I'm more considered about the sustainability parameter, what type of material it is has to be used, what is the operational cost, what is the construction cost, what is the cost at the demolition state, right from initial phase to the end phase. So
Yeah.
in that case, how can I use the traffic analysis one, and how can I use this economic or vehicle let's say vehicle benefits?
Okay. So let us break your question apart into multiple pieces, right? So it goes back to what are the benefits? What are the places where you're trying to define your benefits? So when you're doing an upgrade of the road, well, let's say the 2-lane road remains 2-lane road. We are not going to change that. We're not increasing the number of roads. So there's no impact on travel. So there's no impact on travel time. So there should be no benefits we are identifying from the travel times. Most of your benefits will come from the vehicle operating cost because you are reducing the wear and tear on that. Number 2. Number 3 is you mentioned sustainability, sustainable materials. So when you're using sustainable materials, the cost of actually the cost of uh, the cost of uh, uh, getting rid of it is quite high if it is not sustainable. So that is an aspect which you can incorporate into the benefits. So if you look at the cost at the end of life cycle versus the cost of at the end of the life cycle for the material you're using, that is another benefit you would observe. correct?
Yes, sir.
So that is where you would actually find the benefits. Um, yes, you're creating jobs, but will it create long-term jobs? No, it will only be creating jobs during the construction process. Will it, are you going to create new industries because of that? No, unlikely, because it is not going to substantially change the logistics cost. So you can keep this benefits analysis very simple here. Does that make sense? You're not expecting a wider economic impact analysis. I'll give you I'll give you another example. You must have heard about a recent, I think it was 3-4 months ago. They used lignin, from biochar. From Have you heard of lignin? It is a sticky material which comes out of when you take
Vegetables and all that.
bio waste.
Yes,
Yeah, if you take bio waste,
bio-waste. Yeah.
and you. So what they've been trying to do is trying to use lignin and replace tar.
Okay.
Okay, so now it's a sustainable material, right? Now, where are the benefits showing? The benefits will be, first, of course, that I don't think that there's going to be any impact on the vehicle operating costs. Yeah, because the road quality will remain similar. Okay, so now there's no impact on travel time. There's no impact on um, um, no impact on vehicle operating costs, but there is a reduction in us importing tar and importing oil to produce tar, right? So that can be captured. This is second piece, that you won't be needing tar into for future maintenance and operation. So you can incorporate that, right? So you can look at the life cycle from that perspective. The third one, which is interesting, is the production of lignin never existed in our economy, correct? So you're creating a new industry.
Uh-huh.
So you can actually incorporate that. Lignin is used for other things, but that that whole industry now is going to be is going to support this. So it's going to the use of lignin on roads is going to support that industry, which is going to increase its production, which will result in more jobs and an increase in GDP as well.
Okay. So, sir, in this, do you have any idea or reports you have seen in which all this carbon emission is also seen or observed, like for lignin and all thing, standard way,
So
standard report?
I've seen some UN reports, and usually the way it is done is based on the carbon credits, the cost of carbon credits. So what
Yes,
you would
yes,
do
sir.
is, so y- um, you would what you would do is you would look at the reduction in the carbon footprint over the life cycle, right? Um, yeah, you would look at the reduction in and multiply that with the current carbon credits, right? Like the rate of carbon credits. So I think it's going at around $30 a ton right now, the carbon credits. So you take $30, multiply it with the number of tons you're going to be saving every year, and also put a discounting rate. That would be my initial way of incorporating that. Now, when you end up doing this, people will argue with you that, oh, we don't know, there's a lot of uncertainty in the in the carbon credit cost. So there's a lot of uncertainty. So it can go anywhere from, sometimes it goes down to $15 a ton to almost $75 a ton. So then you have a discussion. All right, what is a more comfortable thing which you would be comfortable with? Based on our assessment, we are using today's price. Based on other reports, we can take a lower value. We can take even 20% lower, and then do that and do the analysis. So the places where people tend to have a lot of arguments is around those assumptions.
Yes, sir. I've gone through this.
actually.
Yeah. Does that make sense?
Yes, sir. Yes, sir.
Oh, but so what
So would
in
you
your
suggest me to consider vehicle operating cost in this? Or I should put a boundary condition for that? Because otherwise it would be a too large one, I guess.
No, you can, but I don't see why there would be an impact on vehicle operating cost, right? So
Yeah.
the quality of the road with the tar and the
Mm.
quality of the road, the of the road with Lingen is supposed to be almost the same. If I relay the road with Lingen, so it's going to be
Okay.
smooth. So there should be no impact on vehicle operating costs. Now, one thing is that they might both deteriorate differently, right? So when the deterioration level starts happening, then vehicle operating costs start playing out. So if let's say it's the other way around, if the but based on initial studies, even the life cycle, right, the period of deterioration, but we don't have enough uh, empirical analysis on this on very many roads. But let's say, for example, that the tar road or asphalt road eh, takes 10 years to uh, it has to be relayed every 5 years. Every kilometer has to be relayed every 5 years. But we might find that it has for Lingen it has to be relayed every 3 years. Now that means there is a period where of 1 year where the quality of the road might be very bad. So you might want to incorporate, but I don't think you should be doing that. I think vehicle operating costs won't make sense in this.
Okay, thank you so much.
Yeah. But how did you solve for the problem around the $20 or $30 on the carbon credits?
So I was thinking of just as you said that lower percent of 20% and higher of so I was thinking of doing lower to 30 and higher to 30.
Yeah,
So
best is to do sensitivity
huh,
analysis, and when you do the sensitivity and sensitivity analysis, you end up
graph.
getting a band,
Yeah, yeah, yeah.
and just compare the band between your two options.
Yes. And that will give me the probable value of the current scenario.
Correct. Yeah. Yeah. Good. There's a there's a very interesting video by Richard Feynman on why two magnets repel each other, right? So so if you're building a model or doing any kind of learning, you should try to gain an intuition of the problem first, and you can ask the question why. You can ask the question why, but you can only go as far to reasonably answer it. So it's a very interesting um, thing. So sometimes when people are being unreasonable about asking why are you making this assumption, uh, what it is, you can this particular video is maybe um, I'll put it in the link, uh, and you guys can look at it in any other questions or thoughts. So what I'm thinking is let's take a bit of a break, and what I want to do is go through some of the in the next this thing is go through some of the uh, ways of actually doing cost analysis. And I'm taking an actual example with the DFC, with the railways. We've got some actual railways data, which I want to kind of go through the different types. Most of the, because it's a very different, like in all your analysis so far, what you all do is, and most of what you have kind of experienced has been doing the economics based on people, travel time savings, people. But there are different concepts when you look at logistics costs, and we will spend some time on that.
Sure, sir.
Sir, one request to you, sir. So
Yeah.
in morning that you show that PPT, can you share with us?
Which one?
First lecture, morning starting, the eco analysis.
Okay. Okay. I think I
NMI
have
model.
all. I think I
NMI
have,
model.
no? Yeah, I have not created. So this is today's lecture is probably a new. I have recreated it based on our discussions over the last 2 days, but everything else is exactly the same as what the lectures that have been slides that have been provided to you. Can
Actually,
you
sir,
check?
yeah, I also checked, but sir, that Excel that you are explaining yesterday, that
Yeah,
calculation, that part you are mentioning in PPT, only the final result.
oh yeah. Okay. Yes. I'll send
That
you PPT. Oh, so yeah,
yeah,
the example, the tutorial
yeah,
example
yes,
PPT,
sir. Hmm.
and the data I've sent you. No,
Yeah. Data we have got it. Yes, sir.
you got both the data.
Yes, we have tried our own, but we did not get any final output. That's why we did not
Okay.
compare it. It is
Okay.
is
Okay. I'll send
right
you
or
this.
wrong.
All good. I'll send you this.
Yes, thank you.
Thank you.
Okay, sir. We'll take a break for 15 minutes and we'll meet back at
Yeah,
11:35 probably, sir.
so let's take maybe if you don't mind, can we start in half an hour? If you
Yes,
don't
sir.
mind.
We can, as you say, sir.
All right. Sounds good. Thank you.
Okay, sir. Thank you, sir.
Thank you, sir.
Thank you.